I'm going to take you through an example on the graphing worksheet that I gave you. First, just to remind you of the format that we're looking at. It has a number divided by x minus a number or x plus a number and then plus or minus another number. And if you remember, the meaning of these three numbers here is m, h, and k. The m value is a vertical stretch. So it takes the function farther away from the x-axis. This value here is the right and left translation. So if it's a positive h or minus a positive h, then it goes to the right. Here, the value takes it up or down. So if it's a minus 3, it would go down by 3. Okay, so basically it's this format here written with numbers here. Okay. I'm going to show you some of the characteristics you can find before you graph it that are going to help you make your graph more accurate. So first thing is vertical asymptote and horizontal asymptote. These values are actually the same as h and k, because remember h and k for the quadratic equation was the vertex, and h and k in the case of the hyperbola function is the middle point at the center of the asymptotes. So, for example, the h value here is 2, and the k value here is minus 3. Those actually become the vertical asymptote, x equals 2, and the horizontal asymptote, y equals negative 3. Okay, so like when it goes up and down, here it goes down by 3, the horizontal asymptote also goes down and becomes y equals negative 3. When it moves 2 to the right, because it's positive 2h, then the vertical asymptote becomes x equals 2 instead of x equals 0. Because remember, the original asymptotes were x equals 0 and y equals 0 for the parent function. And then when you move it 2 to the right and 3 down, you end up with x equals 2 and y equals negative 3. Okay? Once you get the asymptotes, it's very easy to write the domain and the range. The domain is the opposite of the vertical asymptote. Since the vertical asymptote is x equals 2, the domain is going to be x is not equal to 2. And y equals negative 3 is the horizontal asymptote. Well, the range is going to be y is not equal to negative 3. So these all kind of go together, right? Okay, the next part I'm going to talk to you about, which is the x-intercepts and the y-intercepts, further refines your graph, but these are slightly more difficult and take a little bit of algebra. So if you can't do this part, you can still make a decent graph, okay? Let me show you how you would make the graph based on the vertical asymptote and the horizontal asymptote information, okay? First of all, you're going to, I'm going to make the graph part a little bit bigger now. And so take a look at the graph. I've already done part of it for you. Okay, the first thing you're going to do is you're going to draw the asymptotes for the final function. And so the vertical asymptote is x equals 2, so I'm going to draw it through x equals 2. You can see that the squares here are worth 2 and not just worth 1. The horizontal asymptote is y equals negative 3, so it would be this horizontal line here, which is 3 units below the x-axis, okay? So this is going to give you a good guide so that you know where the hyperbola is going to go, okay? So now that you've drawn the asymptotes, let's go back and look at the parent function for this function. Remember that the parent function for this function would be this function without the translation. So instead of 7 over x minus 2 minus 3, you could either do 1 over x, or you could do 7 over x. Let's do 7 over x. We're already going to do the vertical stretch in the parent function. So in this case, I'm going to make a table, an xy table, and I'm going to put in a couple convenient values. And for 7 divided by x, there aren't a lot of convenient values. It's not like the examples we use, 60 and 12 and other numbers that have a lot of different factors. 7 doesn't. But we always know that 7, 1 and 1, 7 are going to work, right? If you put 7 here, 7 divided 7 is 1. If you put 1 here, 7 divided by 1 is 7, okay? Another one that always works is square root of 7, right? If you put square root of 7 here, 7 divided by square root of 7 is square root of 7.
Square root of 7 times square root of 7 is 7. So remember, the square brownie pan always gives you the area here. Okay. Square root of 7, if you do it on your calculator, turns out to be like 2.5, 2.6. All right, just for when we graph here. Okay. So we can draw the blue parent function here, and we're going to graph the points 7. 7 would be right here, comma 1, and 1, comma 7. Those would be the two main points, right? And remember that there is a reflection of this on the opposite side. We could graph negative 7, comma negative 1, negative 1, comma negative 7. That will give us the opposite side of the hyperbola. Okay? So that's the parent function. Now that we have the yellow asymptotes here, we could immediately draw a translated function just by kind of following the asymptotes, right? So you can see that this purple function is the blue function translated. This purple function is this blue function translated. You can even do it a little bit more accurately if you take points such like, let's take this point 1, comma 7, and we're going to take this point and we're going to move it to the right by 2, 1, 2, and then we're going to move it down 3, 1, 2, 3. That would be this point here, right? And then we're going to take this point here, which is square root of 7, comma square root of 7. It's a square cake pan. And we're going to move it over 1, and then move it down 3. We're going to move it over 2, 1, 2, and then we're going to move it down 3. 1, 2, 3, and then we're down here. You see we got two pretty good points here by doing a translation of two of the parent function points. And so now we have a better function. Not only do we know that this purple function follows the asymptotes like that, we also know two of its exact points here. And we do the same thing with this one. We're going to take negative 7, comma negative 1, and we're going to move it 2 to the right, 1, 2, and then we're going to move it 3 down, 1, 2, 3, just below the asymptote. We're going to take this point here, which is about negative 2.6, comma negative 2.6. It's negative square root of 7, comma negative square root of 7. And we're going to move it to the right, 1, 2, and we're going to move it 3 down, 1, 2, 3, and then we end up here. So now we have this purple function, which is the bottom side of the hyperbola. Okay? So you can see I already did a pretty good job of graphing it here, even though I didn't really know the x-intercepts and y-intercepts exactly. Now I'm going to show you, if you're able to do that, how to find the x-intercepts and the y-intercepts. It's a little bit hard. It takes a little bit of algebra. Okay, so for the x-intercept, what you want to do is you want to take this original function here, and you want to put in y equals 0. You're going to substitute in y equals 0, and that will give you the x-coordinate, which goes with the y-coordinate 0. And that's the definition of the x-intercept. The x-intercept is where the function crosses the x-axis, and where it crosses the x-axis, y happens to be 0. So when you want to find the x-intercept, you put in y equals 0. When you want to find the y-intercept, you do the opposite. Because you want to find where the function hits the y-axis, you want to put in x equals 0 because on the y-axis, the x-coordinate happens to be 0. So when you want the y-intercept, you put in x equals 0. Okay? So I'm going to take this equation here where this is y equals 7 divided by x minus 2 minus 3. And I'm going to plug in y equals 0 to find the x-intercept. So I put in y equals 0 here. And then I'm going to do algebra and find out what x equals in this case. Okay? So I'm going to first add 3 to both sides, and then I get 3 equals 7 divided by x minus 2. And then I'm going to cross multiply, and the x minus 2 is going to come up here. There's nothing here to bring up, so it's going to be 3 times x minus 2 equals 7. Then I'm going to divide both sides by 3, and you can do this on your calculator if you want to. 7 divided by 3 turns out to be 2.333 repeating. And then I'm going to add 2 to both sides. And then I get x equals 2.333 plus 2, which happens to be 4.333. So our x-intercept is 4.333. What about our y-intercept? Our y-intercept we find by putting x equals 0 into the substitution, and we put x equals 0 here, and then we end up with 7 over negative 2 minus 3. Negative 7 halves, which is about negative 3.5 precisely, minus 3 gives us negative 6.5. So our y-intercept is negative 6.5.
it's a little bit easier to do the substitution for y-intercept, isn't it? Okay, so we know our y-intercept is negative 6.5. We know our x-intercept is 4.33. Let's check in our graph how well we did with our drawing. So the y-intercept is negative 6.5. That means that this point right here is negative 6.5. And it looks like we did a pretty good job in our drawing. Look, this is negative 2. Remember, each one of these squares is worth 2. This is negative 4. This is negative 6, and it's a little bit lower than that. So that really does look like it's about negative 6.5, doesn't it? Now, to find the x-intercept, we can find by this process here, and we find out it's 4.333. We can see that the purple graph crosses the x-axis about here, right? And remember, these blocks are with 2, so 2, 4, and it's slightly more than 4, so it's about 4.33. We did a pretty good job on this graph too, okay? So just by graphing the parent function and translating it, we got pretty good points here. We didn't really even need to know that. We didn't even need the x-intercept and y-intercept to make a better graph, but sometimes, depending on the graph, it might be good to do this because then you don't need to graph the parent function, okay? So I would say for core, I would graph using the parent function. I think it's a little bit easier. And then if you're going to do extension, I would learn how to find the x-intercept and the y-intercept, okay?